Hello everybody, we start today with a new chapter in physics for ICSE 9th standard, that is heat and energy. Now, as per the reduction in the syllabus for the 9th standard in physics, this particular chapter, which is actually in the textbook given in as 4 parts, the first part being the heat and temperature and anomalous expansion, the second part being energy flow and its importance. This part, the energy flow and importance, has been cancelled. Even the third part, that the energy sources of the different sources of energy, are also been cancelled. And the last part, that is the one which is the greenhouse effect and the global warming, is there. So we have got two sections out of the four which are going to be required to be done as per the new reduced syllabus for 2021. So 9th standard 2021, they will be having the heat and energy chapter only for the first part, that is the heat and temperature, and the last part, that is global warming and the greenhouse effect. So we start with the chapter that is heat and energy. Now, first of all, we know that heat is a form of energy. We know this thing because we know that heat has got the capacity to do work. We can heat, like for example, the best example of heat energy would be steam engine. The heat which is generated by the in the form of steam is going to be allowing the motion of the train. So the engine is going to move based on because of the heat, and that is why heat energy can be converted to mechanical energy. And so we know that heat is a form of energy. So energy, we know it's a capacity to do work. So because heat has got capacity to do work, that's why we can say that heat is a form of energy. Now, so the concept of heat is going to be this way, that heat actually of a body is nothing but the kinetic and the potential energy possessed in the molecules of that particular, so the particles of the body, which the energy possessed by the particles of the body is going to constitute the heat present in the body. So we know it is our common experience that on rubbing our palms, they get heated. We know if we rub our palms, it get heated. Okay. On passing electric current in a metallic wire, the wire gets heated. On burning coal, we get heat. On pumping air in the bicycle tube, the barrel of the pump gets heated. In all these cases, heat is produced either by doing work or by providing energy in some form of the other than heat. So either the heat is generated by doing some work, so when some work is done, the heat is generated or heat is going to be formed, or it is converting one form of energy into another form of energy which is going to produce the heat. So that's why when we are rubbing this thing, what we are doing is we are converting the mechanical energy, that is the friction, into heat energy. So it is because of friction that the heat is being generated in the hand. Similarly, when the cycle के pump हवा भर रहे हैं, तो pump जो है हम लोग when we start pumping the pump, the pump gets heated up. After a few pumps, you will find that the pump is getting heated up. That is of course because of the friction which is generated inside. And then we have got many other examples over here, like the passage of electric current. The bulb जब चालू करते तो bulb gets heated up. So again, that is because of the passage of electric current. So electric energy getting converted to heat energy, or heating of the coils of the oven or toaster. All these are examples of heat getting generated. On rubbing palms and on pumping air in the bicycle tube, heat is produced by doing work. So we are working on that pump, or we are doing the work against this thing. So again, we are doing work, and accordingly the heat is generated. That is from mechanical energy. Of course, there is an energy change from one form to another form, but at the same time we know that there is some motion taking place due to which is going to be there. So some work is done, and due to the work done, there is the heat generated. So heat is produced doing work from mechanical energy, while on passing current in metallic wire, heat is obtained from electrical energy, and on burning coal, heat is obtained from chemical energy. Thus, heat is also a form of energy, because we know that heat is a, how could we say that heat is a form of energy? Because energy can neither be created nor be destroyed. So it can be only be transformed from one form to another form. So here what is happening is that heat, because heat is being produced from one form of energy, so automatically the other form of energy क्या हो गया, heat हो गया. So heat is a form of energy. Each each body is made up of molecules. So now let's understand the concept of heat, or we can say understand the how the heat is present in a body. So each body is made up of molecules. So molecules are in random motion, and each molecules exert a force of attraction on other molecules. Thus, molecules possess energy, and the heat energy of the body is the internal energy of its molecules. So we know very well that if there is a particular kind of a substance, so if this is a substance, and if these are the molecules of the substance, these molecules of the substance over here, they are going to be in random motion, and they will be first of all vibrating against about the mean position. So they are going to collide with the other particles, and the collision which is going to take place, the first of all the motion is going to take place, and the collision which is going to take place is going to cause the heat energy, or we can say it is the internal energy possessed by the molecules of the body. So that's why we see that the molecules possess energy, and the heat energy of the body is the internal energy of its molecules. A hot body has more internal energy than an identical cold body. When a hot body is kept in contact with a cold body warms up and the hot body cools down. So you will find that this thing, suppose I start heating this thing. So if I start heating this particular solid material, then these vibrations are going to keep on increasing. So that increase in the vibration means there is more energy being imparted to the substance, or you can say that more the energy present, more will be the internal energy what will be there, more will be the kinetic energy presence inside, or more will be the molecules movement inside the substance. Also, it is found that when two hot bodies are kept in contact with, so if this is a hot body and this is a cold body, suppose this is 100 degrees Celsius and this is at 50 or let's say 40 degrees Celsius, and then if they are connected together, so agar maine isko connect kiya, what will happen is that slowly and steadily the heat from here is going to travel and give you a here till the time that both of them are going to be at the same level. So when this also reduces and this also increases, so both of them are going to come to 70 degrees. इसमें से 30 degree जाएगा, इसमें से 30 degree add on होगा. According this becomes 70 and this becomes 70. So that's why we see that the hot body, when it is kept in contact with the cold body, the hot body loses its energy, whereas the cold body accepts the energy, and it is found that the hot body cools down, whereas the cold body heats up. So the heat is going to be transferred from one object to another object. So when a hot body is kept in contact with a cold body, the cold body warms up and the hot body cools down. That is, the internal energy of the cold body increases and that of the hot body decreases. Thus, energy is transferred from hot body to the cold body when they are placed in contact. The energy which flows from hot body to cold body is called the heat energy, or simply heat. So the energy which is going to travel from one body to another body in the form of the kinetic energy increasing from one point to another point, or we can say the energy which is moving from here to here, that energy is called as the heat energy or just heat. On touching a body appears too hot to us when heat energy flows from the body to our hand. So you will find that when I touch, suppose I take this pen, okay, if I take this pen and when I touch this pen, if I feel that the pen is cold, in that case what is happening? My heat, the body heat from my body is going to travel to the pen. So that's why I feel it cold, because the heat is getting transferred from my body into this thing. So my body is at a higher temperature, or you can say higher amount of heat energy than this. So heat is transferring from me to the pen. Suppose I find that this particular pen, when I touch it, it feels hot to me. That means the energy, the heat energy from the pen is traveling into my body. So whenever you feel, when you're on touching a particular object, when you feel it to be hot, that means the energy is traveling from that hot body to your body. And if you touch the body and you find that it is cold, then the body is said to be a cold body. That means a body is going to be my body is going to give away energy to the cold body. So this way you feel that on touching, a body appears hot to us when heat energy flows from the body to our hand, while appears cold to us when the heat energy flows from our hand to the body. For example, if we touch warm water, we feel hot because heat energy from the warm water passes to our hand. Similarly, if we touch a cube of ice, we feel cool because heat energy from our hand passes to the cube of the ice. Thus, we can define heat is the internal energy of molecules constituting the body. It flows from hot body to a cold body. So you can define heat as heat is the internal energy of the molecules constituting the body. It is the internal energy of the molecules constituting the body, and it always travels from a hot body to a cold. So it flows from a hot body to a cold body. So that is the definition of heat energy, that heat energy is the internal energy. It is the internal energy of the molecules constituting the body, and it flows from hot body to cold body. The next one we see is the unit of heat. Now heat, because it is a form of energy, that's why the first unit of heat will be, of course, joule. But because joule is there for many different kinds of heat energies, that's why there is a special kind of thing which is called as calorie. So calorie is the basic unit, or can see the unit for heat energy. So the unit of heat is same as energy. The SI unit of heat is joule, and the CGS unit is erg. 1 joule is equal to 10⁷ erg. So we know here that the relationship between 1 joule is equal to 10⁷ erg. This is the relationship between the CGS and the SI unit. So SI unit and CGS unit is joule and erg. Other unit of heat are calorie and kilocalorie, where 1 kilocalorie, so 1 kilocalorie is equal to 1000 calorie. And also it is seen that the unit of calorie and joule are related as 1 calorie is equal to 4.186 joule. So that's the thing, that 1 calorie, or we can directly say approximately equal to 4.2 joule. So 1 calorie is equal to 4.186 or 4.2 joule. So when I talk about the joule and calorie, then the relationship between them will be given by 1 calorie is 4.18 or 4.2 joule. So that's the unit of heat. So heat can be measured in joule, which is a normal one for any kind of energy, or it could be specialized in case of calorie. So the calorie, the unit of calorie, for the relationship between calorie and joule is that 1 calorie is equal to 4.186 or 4.2 joule. Whereas the calorie is a smaller unit, a bigger unit will be kilocalorie, which is 1000 calorie is 1 kilocalorie. Now let's understand the concept of temperature. So first thing was the heat, but heat we cannot directly calculate. We cannot find out the amount of heat present in my body or in this pen. I cannot just find out the heat so easily. So normally, to identify the degree of hotness or coldness of the body, we use the term temperature. So the next thing what we use is temperature. So you can see that the temperature is the one, like for example in the example which I gave you over here, that 100 degrees पे है और ये 40 degrees पे है. So I gave you the example of temperature because that is how you identify as a hot body and a cold body. So we can say that temperature will be that physical quantity which is going to identify the flow of flow of the heat from higher temperature to lower temperature, or we can say it is the degree of hotness or coldness of the body. So we see temperature, the concept of temperature. When a body is kept in contact with a cold body, it is noticed that after some time the hot body becomes less hot and cold body becomes less cold. Obviously, this is because of the flow of heat from hot body to cold body. the body which imparts heat is said to be at a higher temperature than the body which receives the heat. Thus temperature determines the direction of the flow of heat. So that's what we told you, that this one is going to become 70 and this also is going to become 70. So accordingly we see that both of them are going to become 70 degrees Celsius, wherein it is seen that the hot body has lost the heat and the cold body has gained heat. So that's why it is so happening that the change in the temperature is going to be the key, or the change in temperature is going to identify whether the body is going to accept heat or it is going to give out heat. So that's why we have that the flow of heat from one body to from hot body to cold body is always going to, the flow of heat is always going to be from hot body to cold body. So body which imparts heat is said to be as the higher temperature. So this one is imparting the heat, so it's at the higher temperature, and because this is going to accept the heat, that is why it is called as the receive the heat is called as the lower temperature. So temperature determines, so what we say is that temperature determines the flow of direction of the heat. So direction of flow of heat is going to be determined by the temperature of the body. When a body receives heat, the particles constituting the body starts vibrating more vigorously and its temperature rises provided its physical state and dimensions remains unchanged. So it is seen that if this body is heated, the vibrations of this particular, that is the internal energy of that particular molecules are going to increase, and this is going to increase till the time that it does not change its state. So the change in temperature is going to take place only if there is no change in the state, that is no physical change in the body. So if it is going to be heated, it is going to vibrate more vigorously by that, and that is how its temperature is going to rise provided the physical state of our and dimensions are going to remain unchanged. Thus temperature is defined as, so now this gives us the definition of the temperature as: temperature is a quantity which tells the thermal state of the body. So it is that physical quantity which tells us the thermal state of the body. Means what? Whether it is hot or cold. Okay. So it is going to tell you the thermal state of the body, that is the degree of hotness or coldness of the body. Okay. That is what? That is the degree of hotness or coldness of the body. It determines the direction of the flow of heat when two bodies at different temperatures are placed in contact. So another important thing about the temperature is that it determines the direction of the flow of the heat when two bodies are kept in contact with each other. So this is how the temperature is going to be defined, or we can say the temperature is defined as the quantity which determines, which tells us or determines the thermal state of the body, that is the degree of hotness or coldness of the body, and is going to determine the direction of the flow of heat when two bodies are kept in contact with each other. Over here. So that is about the temperature. Now if there is no transfer of heat between the two bodies placed in contact, they are said to be at the same temperature, but it does not mean that they have equal amount of heat in them. In fact, the temperature alone does not tell us the quantity of heat energy contained in them. Experimentally, we find that by imparting same quantity of heat energy of two different bodies, they get heated to different temperatures. The amount of heat energy contained in the body depends on its mass, temperature and material of the body. So we can see that the temperature alone is not going to tell you the amount of the heat energy present in it. Now this is quite easily understood by the fact that you will find that अगर sun में, okay, in when you are in, it's a hot summer day, and a hot summer day you have kept two chairs on your let's say the terrace. Okay, तो terrace पे हम लोग ने दो chairs रखे थे. One is a metallic chair and other is a wooden chair. Okay, what happens? Can you sit on that metallic chair? No, you'll find it too hot. Whereas you can easily sit on the wooden chair. Why is that so? Because both were in the sun for the same amount of time. Both were there in the sun for the same amount of heat is there on it. But still, the wooden one you can easily sit on because it is not so hot. Whereas the one which was the metal one would have got so hot that if you try to sit, to barabar se chatka lagega. So that's why you're not going to sit over there, right? So that's why you'll find that same amount of heat was given to both these things, but the temperature of that particular thing rise to a different level. The same thing would be a condition if I take a cooking pan, and a cooking pan is put on the gas burner, and the heating is started. Now, can you touch the cooking pan? No, you cannot touch the cooking pan. But can you touch the handle? Yes, you can touch the handle. Handle also gets the same amount of heat as, because they are in conduction से, इसीलिए handle also gets the same amount of thing as compared to the pan. Okay, वही handle अगर समझो wooden handle या plastic handle के बदले अगर iron का handle होगा तो can you touch it? No, you cannot touch that because the same amount of heat will be passing over there also. So the temperature will be the same in both the cases. So it is seen that it is not, or we can see that it is not necessary that two substances having the same temperature has the same amount of heat, okay, or having the same amount of heat are in the same temperature. It may happen that one body will have more amount of heat even if the temperature is less, and the other body can have less amount of heat even if the temperature is more. Like an iron will have more temperature but less amount of heat in it, whereas water will have more amount of heat with a less amount of temperature in it. So accordingly you will find that the heat and temperature is not that if the temperature is the same, I cannot say that the heat is going to be the same. If the temperature is different, I cannot say the heat can be different. It can be possible that even if the temperatures are different, that the heat present inside is same. So the heat present inside is going to depend upon three factors. The first one is the mass of the body. Okay. The second one will be the what was that? It is about mass of temperature. That's it. The temperature, the heat is also going to depend upon the temperature, and the third one, it is depending upon the material of the body. So these are the three things on which the heat is going to be dependent. So heat is going to be dependent on three factors. First is the mass. More the mass, more the heat, right? If both the substances are same, if both are water, 1 liter water and 10 liter water, अगर दोनों के अंदर दोनों का temperature same है, तो जिसका quantity ज़्यादा उसका heat ज़्यादा. So mass के ऊपर डिपेंड करेगा. Secondly will be depend on temperature. If one is at 10 degrees, other is 20 degrees, same water is there, same quantity water, 1 liter water here. If one is 10 degrees, other is 20 degrees, then what will have more number of heat? The amount of heat will be more in case of 20 liter water or 20 degrees Celsius, sorry. Right, and finally the material. So it will depend upon whether it is a good conductor or bad conductor. Iron के अंदर the amount of heat will be less as compared to water. Water को temperature के हिसाब से अगर देखा जाए तो if both are them in the same temperature and the mass is also same, but one is water and the steel will have less amount of heat, whereas water will have more amount of heat. So this is how that you are identifying the heat and the temperature. So temperature cannot be, it can only give the direction of the amount of heat transfer, but it cannot determine how much amount of heat is present in that particular body. Okay, the temperature does not identify the amount of heat present in it, it just gives the direction of the flow of heat. Unit of temperature, the SI unit of temperature is Kelvin, that is K, and the temperature it is referred as Kelvin, that is Kelvin is K, and the other common unit of temperature are degree Celsius, symbol degree Celsius, and degree Fahrenheit, so degree F. The temperature of Celsius scale and Kelvin scale are related as T Kelvin is equals to 273 plus 2 degrees Celsius. So by adding 273 to the degree Celsius ka value, you get the Kelvin ka value. So if presently if it is 27 degrees Celsius, then 27 plus 273, that is 300 Kelvin will be the temperature out right now. So if the temperature right now is 27 degrees Celsius, it means it is 300 Kelvin. So We get a temperature of Kelvin. Actually, a degree on both Kelvin and Celsius scale is the equal. So 1 degree rise in Kelvin is equal to 1 degree rise in Celsius. So अगर यहाँ पे the temperature is increasing from 27 to 30, that means 3 degree rise. तो यहाँ पे 300 to 303 होगा. So degree rise is the same. The levels are the same, but only thing is that the base value. So 0 degree Celsius is equal to 273 Kelvin. So that's the main thing. The ice point or 0 degree Celsius in scale is 32 Fahrenheit on Fahrenheit scale and 273 Kelvin on the Kelvin scale. The steam point 100 degree Celsius on Celsius scale is 212 Fahrenheit on Fahrenheit scale and 373 Kelvin on the Kelvin scale. So thus there are 100 equal degrees between the ice point and the steam point on both the Celsius scale and Kelvin scale, but 180 equal divisions of Fahrenheit scale. Thus 1 degree on Celsius scale is 9 upon 5 degree on Fahrenheit scale. The zero on the Kelvin scale is called absolute zero, and it is a temperature when molecular motion ceases. It is at minus 273 degrees Celsius, that is 0 Kelvin is equal to minus 273 degrees Celsius. The temperature of Celsius and Fahrenheit scale are rated as C upon 5 is equals to, so it is C upon 5 is equals to F minus 32 upon 9. So this is the Kelvin to Fahrenheit to degree Celsius ka conversion. So conversion for Fahrenheit to degree Celsius, you are using this particular thing. You don't have sums on that, so don't worry about it. So nothing like that. Okay, now so we can see over here that the Kelvin scale starts with 0, and that 0 is equals to minus 273 degrees Celsius, and that is absolute 0, means it is that particular temperature wherein all the molecules will cease their any motion. So at 0 degree Kelvin, it was at 0 Kelvin, you will find 0, it's never degree Kelvin, that's why I just rectified it. It's 0 Kelvin. Kelvin is not degree Kelvin, so okay, so degree Kelvin. So at 0 Kelvin, the molecules will be completely stationary. They will not be having vibrational motion at all. So that's called as the absolute zero. So absolute zero is 0 Kelvin, which is minus 273 degree Celsius. So we have the difference between heat and temperature. Heat is a form of energy obtained due to random motion of the molecules in a substance. So heat is the energy obtained in the random molecular motion. And temperature is a quantity which determines the direction of flow of heat on keeping two bodies in different temperature in contact. SI unit of heat is joule, SI unit of temperature is Kelvin. The amount of heat energy and heat contained in a body depends on the mass, temperature and material, whereas the temperature of the body depends on the average kinetic energy of its molecules due to their random motion. Heat is measured by the principle of calorimetry. You have a complete chapter based on calorimetry in the 10th standard. So it's principle of calorimetry, whereas temperature is measured by thermometer. Two bodies having same quantity of heat may differ in their temperature. Two bodies have same temperature may differ in quantities of heat content in them. So when you're talking about the two bodies having same quantity of heat, they may have different temperatures, whereas if two bodies have the same temperature, then they can have different amount of heat present in them. Finally, very important, when two bodies are placed in contact, the total amount of heat is equal to the sum of the heat of the individual bodies. That means if this has got 100 joule of heat and this has got another 100 joule of heat, when I'm bringing it together, I can say that I'm having 200 joule of heat energy in them. But in case of temperature, when two bodies of different temperature are placed in contact, the resultant temperature is the temperature between the two temperatures. That means if this I say is at 24 degrees Celsius and this is at 30 degrees Celsius, I cannot hold them together and say हाँ अभी ये दोनों का 20 plus 30 and 50 degrees Celsius हो गया. No, it cannot happen this way. If this is 20 and this is 30, then the resultant will be something in between 20 and 30. Okay, the resultant temperature will be in something in between the two temperatures of the body. Okay, it cannot be an additive quantity. So the temperature is not an additive quantity, whereas the heat is an additive quantity. Heat can be added up. Heat of this and heat of this can be added up to form the heat, total heat. Whereas the temperature of this and temperature of this cannot be added up. The sum of these two will be a value in between the higher and the lower values of this thing. So that is the difference between the heat and temperature. So there are 6 points over here. Very, very important point over here, the distinction between heat and temperature. So we now move on to the thermal expansion, but in the next video.